this is where it gets fun. We have our formula, XL, which we know to be a form of opposition measured in ohms, inductive reactance. It is the coil reacting to the changing magnetic field in it, inducing its back voltage and providing opposition. How is that formed? 2 pi for life. Two variables over here. Frequency. I can't do much about the frequency here. 60 hertz out of the wall. And inductance. Now I can change the inductance on this guy. I know how to do that. But either one of those will cause this to change. If frequency were to increase, XL would also increase. And why is that? Well, the current is changing faster and faster and faster, meaning that the magnetic field is changing faster and faster. More change, more opposition. But like I said, I got 60 hertz coming out of the wall. Inductance, how can I change that? We know our properties. Number of turns, cross-sectional area, if I put a core in there, and the length of the inductor. How tight are they wound together? Okay. Oh, I had a calculator here. Had to double check these numbers would work out because I don't want to do anything bad. Because here's the thing. I've got about 200 feet of number 18 wire. And if you look in your tape, what is it, chapter 9, table 8, you're going to find that that comes out to about 2 ohms, plus or minus. And if I have 2 ohms of resistance with 120 volts, that's about 60 amps. That's not good for this little wire. That's not good for this circuit. So I already have some reactance because it's coiled up. The wire is coiled up. I have some reactance. But I don't think that's enough. Let's try it. Ooh, what did you see on the current there? Take a look at that again. I'm up to 40 amps or so. Okay, got to turn that off real quick because if I left that for too long, the breaker would trip. Okay, how am I going to slow that down so I have less amps? Well, if I start putting iron in the core, if I put this in here, will that concentrate the lines of flux? Will that increase the inductance there? I think it will. Ooh, the wire got a little warm. I'm going to increase my inductance and therefore increase my opposition, my XL measured in ohms. And if I increase that enough, then what? I could probably leave this on and run a current for a while. Let's see what happens. I basically have this coil plugged in. Let's see what happens. Ooh, they jumped around. But I've got 8 amps. 8 amps flowing. If I were to pull these out, what's that going to do to my amperage? More and more and more. How about if I just pull out, say, 3 of them? Now these things, this magnetic field here, there's a lot of pull on each other. Ooh, we're up to 12 amps. Pull out another one. Because I'm reducing the inductance and therefore reducing the opposition so more current is flowing. I gotta stop this thing. I gotta put more of these back in here. Let's turn that off for a second. Put them all back in here. See how they settle down? Watch that. Quite magnetized in there. Yeah. And you know what? These things got warm too. They got warm. As did the coil.